Hello, friends. Thank you for joining me today. My name is Riaan Nolan, and I'm a HashiCorp ambassador. And in today's episode, I'd like to tell you a little bit more about the various products and tools from HashiCorp. And using HashiQube, a DevOps lab that I've created, I'd like to help you to get started with these tools. Now, friends, before we get into the various products from HashiCorp, I think it's just worthwhile touching on a concept that HashiCorp is calling their cloud operating model. Now, this cloud operating model breaks the various of stages of a cloud adoption down into 4 sectors. Now, their products fit into these sections. For example, when we talk about infrastructure, the foundational layer, Terraform and Packer forms part of this foundational infrastructure layer, this part of adopting the cloud. Then, on top of that, is security. And with security involved, Vault and Boundary can help you broker access to services and store your secrets for you. Then a layer on top of that is how do we connect these different infrastructure components? And for that, we use Console, which is a DNS or a service mesh. And then at the very top sits our application layer. And for that, we can use Nomad, which is a job orchestrator or a container orchestration, and Waypoint, which enables developers to quickly and efficiently deploy workloads onto Kubernetes, ECS, or Nomad, or any other cloud service that Waypoint supports currently. So, friends, let's keep this interesting. Which HashiCorp product did not feature on the previous slide? Feel free to rewind, have a look, and I'm going to give you a hint. It is HashiCorp's first product. So, good luck, and in the next slide, make your choice. Congratulations, you have guessed correctly. It was Vagrant. So, bit of a trick question because I also added Sentinel in there. And while Sentinel is a framework that HashiCorp has released for policy in code, it is not one of their official products. Therefore, Sentinel is not one of the options. The other choice I put there was HashiCorp, and of course, that's also not an option. I also added Terraform as a choice, but Terraform did in fact feature under the infrastructure section of the cloud adoption model. And the correct answer was, as you have no doubt guessed, Vagrant. Now, friends, let me tell you a little bit more about Vagrant. Vagrant is a product from HashiCorp, their very first product. It is created to help you create developer environments all defined in code, meaning that we can write a Vagrant file and define our development environment, everything in code, the networking, the shared folders, which is mounted, the ports, the access, and in addition, we can specify provisioners, meaning we can run certain scripts at startup when this developer environment is booted. And I'll shortly show you an example of that. HashiCube is built using Vagrant. What makes Vagrant even more amazing is that it is using a plugin architecture, meaning that Vagrant supports VirtualBox, meaning if you run VirtualBox if you run Vagrant with a VirtualBox provider, you will get a VM on your laptop as your developer environment. If you run Vagrant with the Docker provider, your developer environment will be using Docker. Now, if we go to the Vagrant website, which is this one over here, we can hit the documentation, docs. And in this documentation site of Vagrant, we will be able to read up about the networking, the boxes, the Vagrant file, and the providers. A quick example of this providers over here is exactly what I've just mentioned to you. You can get a VirtualBox provider, or a VMware provider, or a Docker provider, or Hyper-V. Meaning that if we use the Docker provider, which HashiCube uses by default, our developer environment will be a Docker container. Now, let me show you an example of a Vagrant file. This is HashiCube's Vagrant file. So if you clone HashiCube repository, you can open up the Vagrant file over here, and this is what you will see. Now we can set some defaults at the top, meaning that by default, HashiCube uses the Docker Vagrant provider. Meaning if we go Vagrant up -- provision, we will have a Docker container on our laptop. Now, I've already run provision, meaning that when we do Vagrant -global status like this, we can see that we have a machine running HashiCube in this directory. It's using the Docker provider. It's in this running state, and this is the directory, meaning the current one we are in. If we then do Docker PS, we will see that here is our developer environment, a Docker container. Now, all of these ports you see over here are ports mapped by our Vagrant file. So let's see how that is done. At the top, we can specify some VirtualBox configuration. However, this is no longer the default. I just want to make you aware that we can specify RAM, CPUs, all of these configurations at this link that you can get to our Vagrant box. We can also specify shared folders, the size of our initial disk, an IP address, and our SSH port. Now, if we scroll down, we can see that we have mapped all of our ports over here, and these are the different services and integrations that HashiCube supports. And we can go down and we can see our providers. So here is our VirtualBox provider. This is no longer the default. However, if you want to run HashiCube as a virtual machine, you can still do so. Here is a Hyper-V provider. And more importantly, the default one is our Docker provider. Now, we can specify some parameters to this provider, meaning we can say privilege, that our container will be running as root. It has SSH, and we want to keep it running. We can also specify Docker create arguments to it, and here we map mounts and file system into this container, meaning we can specify tempfs and mount it inside the container on var lib docker with the following file system properties. We do this for the reason that we want to run a Docker container inside of a Docker container, and we want to run Minikube and Nomad inside of a Docker container. I'll get more into this later on. For now, just remember that you can define your developer environments in a Vagrant file. This is extremely important, so that you can check this into your source version control and keep records of this. Now, I've briefly touched on provisioners. Now, provisioners could just be a shell script, and I use this for HashiCube. It is mainly just a shell script and at this path. So if I show you what this looks like in the folder, HashiCube, there is a basetools.sh, and this is mainly just installing packages for us. Things like curl, things like unzip, things like Python, virtual environments, Go, Nano, IP tables, all of the tools that HashiCube will need to run. It also sets an MOTD file for us, and we're out of there. Meaning that when we go Vagrant SSH, we are inside of HashiCube. We can see here is our MOTD for us, and we can see df-h. Here is our var lib docker mounted as tempfs into our container. So when we exit here, Let me show you an example of a provisioner. So we can go Vagrant up, minus minus provision, minus with Vault. And these provisioners run extremely quickly. We are going to install Vault, download it, set a config file, and start Vault, meaning that our port for Vault has now been forwarded from our localhost into the container. So let's open up this URL for Vault. And we get our Vault login page. Now we need our Vault token, and we can copy this and we can log in over here. Vagrant is extremely powerful, friends. I really recommend you use it. Now, some people might say, why can't we use Docker Compose? Friends, you absolutely can. However, Docker Compose is not as powerful as Vagrant. With Vagrant, you can run virtual machines and Docker containers. You can mount directories, you can specify everything in code, and more importantly, you can run certain files at startup, meaning I can do Vagrant up minus minus provision minus with Vault or base tools. And this is the customization that we are looking for in these developer environments. So friends, next up, I'm going to tell you a little bit more about Vault, and thank you very much for your time. Let me tell you a little bit more about HashiCorp Vault. Primarily, Vault is a secrets engine, meaning it can store your passwords and secret data like certificates for you. But Vault can also do a lot more. Vault have secrets engines, and amongst other is database, meaning that Vault can create database users for you and manage their TTL, their time to live, meaning we no longer need to create users in MySQL. We only create one user for Vault with the correct permissions to be able to create more database users and assign them privileges to databases. In our Vault policy, we can specify a time to live, and Vault will remove this user for us. Now, Vault comes in the Community Edition, which I run in HashiQube to be able to demo and showcase these capabilities. However, you can also get Vault Enterprise, and this you can install on-prem on your EC2 servers in your cloud or on-prem on your VMware machines. Vault Enterprise has some additional capabilities such as performance replication and clustering, amongst other. But I would also like to show you Vault on the HashiCorp Cloud platform. So if you go to portal.cloud.hashicorp.com and you create yourself a user, you will see Vault on the left-hand menu. Now, I do not have an active Vault in the HashiCorp Cloud platform, but I want to show you also Vault Secrets. Now, Vault Secrets is a kind of minimalistic service from HashiCorp Cloud platform, and it is free at the moment, meaning that anyone can use it. You are just limited by the amount of secrets that you can use. I will show you shortly how I use this within HashiCube to help you practice and learn Vault. If we go to Vault Secrets, we can see that I have an application configured called HashiCube, and I've got one secret in there. Now, I can expose this secret, copy it and paste it, and I'm sure that my secrets are protected in a single source of the truth, meaning HashiCorp Cloud platform. Now, I've said to you that you can also run Vault on your own machines. And I have done this in HashiCube, meaning that if I go to localhost 8200, I get to the Vault login. And the reason I get to the Vault login is I've already done Vagrant up minus minus provision minus with Vault. So when I type in Vault, the Vault provisional will run, It will see that Vault is already installed and unsealed, and it will output my Vault token. So if I copy this Vault token and I go back to my Vault login page, I can log in. Now, I can see that similarly to Vault secrets, I've already set a secret over here. So let's see in my key value version 2 secrets engine what my secret is. So here is a value, another test, and this value is another test value, a secret value. I've also created a password, and here you can see my super secret password. Now, I explained to you briefly that Vault is much more than just a place to store your secrets. Let me quickly show you, using HashiCube, how Vault can create MySQL users for you. So, going back to Vagrant, we are going to run Vagrant up --provision -with MySQL. And all that this will do is it will run in the databases mysql.sh for us. It is going to bring up a MySQL Docker container, of which we can specify a username and password, meaning that this Docker container will run in HashiCube. And we effectively have a MySQL database that we can use for our testing and integration. We will just give it some time to launch. Maybe while it's taking time to launch, I'd like to show you the MySQL provisioner. Here, I've left you some links. Here we clean up old running MySQL containers that we've already tested with. We discover what architecture we are running on, and then we ensure that Vault is running. If Vault is not running, it will start it for us. Now we bring up a MySQL Docker container, and we set the MySQL root password to password, and we create the initial database. Now we will do show databases, excuse me, and we will create a Vault user for MySQL. And this is just a MySQL query that we go create user Vault at %, any host, identified by password. So if we now, we also are going to grant Vault access. We granted all privileges on all databases, and we can create a user on this user Vault. So Vault has the ability to create users and assign these privileges to databases that exist. Then we are going to enable the Vault secrets engine, and this you will be able to see in our secrets engines. Here is the database secrets engine enabled. Now we will create a Vault database config, and this is the Vault database config for MySQL DB, the plugin MySQL database plugin, the connection URL, and we will say the allowed role in Vault with a Vault username and password. Now we need to create a role for Vault. This is what Vault will use to create the database users. So you can see the create statement is create user, the user at the host, identified by the password, and then we are granting all privileges on MySQL DB star to this user with a default time to live of 5 minutes. Therefore, if we now view our users, and for that, we are going to go to HashiCube, and we're going to go Vagrant SSH, we can post this MySQL query. And we can see that the Vault user that Vault has created a user for us in this database, in addition to the Vault user. Now, we can then use this database user and password, so meaning this username and this password, which it still exists, to view the databases, meaning we can go select, we can go MySQL-u, this username, -p, this password, -h, 127.0.0.1, and we can show databases. Right. Now, if we wait a couple of minutes, Vault should remove this user. So let's see how Vault does that. So this is important, that it is actually Vault removing these databases for us. So let's go here, and we are just going to select the users over here in MySQL, quit. And we can see that the users still exist. And we will give it a couple of seconds, and I will show you that in a minute or two, this user will no longer be present. Vault has removed it. So quickly circling back to HashiCube. HashiCube supports a number of services and integrations. One of these are MySQL. Another one is GitLab and also AWS Ansible Tower. Also Jenkins. Now, if we go to HashiCube.com and you want to see how we are going to use Vault secrets and Vault with a Jenkins pipeline, then you are able to scroll down to Jenkins. And when you click here, you can read a little bit about Jenkins. What we are going to do, we are going to retrieve secrets from Vault in HashiCube, and we're going to retrieve secrets from HCP Vault secrets from the HashiCorp cloud platform, and we are going to use this in our pipeline. Now, friends, if you follow this tutorial, you can run your Vagrant up with your provision command that will bring up the base tools, Docker, Doxify for your local documentation, Vault, and Jenkins. And you will see output that looks like this. If you keep on scrolling down, I will take you through the Jenkins setup, how to log in, retrieve your token, go through the plugin updates, create your first admin user, and then use Jenkins. Now in Jenkins, we are going to use the Vault plugin, and we are going to install this Vault plugin, and we are going to configure it. Now, here in Vault, we will enable our key value secrets engines on the Vault on HashiCube local, and we can then use this little bit of Groovy code in our Jenkins file to retrieve these secrets. Now, let me show you the entire Jenkins file. Sorry, before we get there, here is our Vault secrets on HashiCorp Cloud Platform. And you can follow this entire tutorial. I'll show you how to create your first application and secret. And then we are going to use this in Jenkins. We can configure it. We store the secret. And now we can use this little bit of Groovy code that I've placed here for you to retrieve secrets from Vault that's running on your local host via HashiCube, retrieve a secret that's running on Vault secrets on the HashiCorp Cloud Platform, and using the CLI integration, run Terraform on HashiCorp on Terraform Cloud. All of this using a Jenkins file, everything defined as code. So, lastly, that user should now have been expired. 5 minutes has passed, and let's see whether Vault has removed this user for us. And we can see that this user is no longer available. Vault doesn't just necessarily have to remove it for us. It can also rotate the secrets, meaning that database secrets, even if they are leaked, they no longer exist after a certain amount of time. Vault is incredibly, incredibly powerful. So friends, thank you very much for joining me today. And next up, I'm going to show you Consul. Now, the product Consul from HashiCorp does a number of things for us. One, it sorts out discovery, meaning that in the old world, we had a monolith, very much hard-coded IPs and firewalls that says that web server can talk to database. But in today's microservices world,
We might have many web server fleets doing different functions, talking to many, many databases. And these things scale up and down as they auto scale. So how do we now make these services more dynamic and discoverable? And so Consul is primarily looking at that. Consul is a DNS, meaning that I can query Consul to get an IP from it. And it's a service discovery, meaning that it has got a couple of services, a catalog, where the services register to Consul. And then Consul can return the status of the service. Is it up or down? In addition, Consul can also store key value pairs, and it can then write this to a template using Consul template. So meaning that in our monolith world, we used to have one single config file. And let's say we wanted to turn maintenance mode on or off. Now in this microservices world, how do we distribute this setting very quickly? Well, we can use Consul template to do that, meaning we can set in Consul's key value space, we can set maintenance mode equals true, and Consul template will roll this out for us. But let me show you what I actually mean by this. So I have already run Vagrant up -- provision with Consul. Now, again, just touching on this, Consul can run as a community edition on your own laptop, where we can proof of concept and minimum viable products these integrations. But Consul has also got an enterprise binary that you can run on-prem or in the cloud on your EC2 machines or Google Compute instances. Or you can run this on HashiCorp Cloud Platform, where HashiCorp will take care of the maintenance, upgrades, and managing of these Consul instances for you. And you can literally just focus on what is important: your application, your customers. But today, we have run Vagrant up -- provision with Consul, and we should be able to go to port 8500. Now, immediately what you see is we see an overview and cluster overview, meaning we have got an active voter, one instance in there, which is HashiQube. You can have many across many database data centers. But for this proof of concept in HashiQube, we have one. And then if we look at services, we've got a number of services. Now, let's say we want to look at Vault. So in this service stanza, it tells us that Vault is active, all the checks are passing, and this is the IP address 8200. And this is the routing, it goes straight to Vault. So let's look quickly what that means. If we go into HashiCube and we go Vagrant SSH, now in etc resolve.conf, we have set our current IP as DNS, meaning that Consul is listening on 8600 for DNS queries, meaning we can go dig vault.service.consul at localhost, and we want the ARET port. Boom. And there we go. It is using DNS mask to forward this query on port 53 to 8600. So this is where this little gotcha is coming from, right? But I cannot dig Riaan.service.consul because it does not exist there. It is returning that it cannot find it. But I can dig Consul. Now, let me show you where this comes from. So if we open up HashiCube, the GitHub repository, and we look at Consul, what we are doing is we are discovering which architecture we are on. We are installing some dependencies. Now we are setting a Consul server.HashiCorp configuration language, server config file. And we are telling that Consul Connect is enabled. We enable the service config. We're telling it what recursors and forwarders we are looking for to forward DNS queries that's not managed. And then we also enable the telemetry block of code. Now, the telemetry is very interesting. Using this service registry, we can tell Prometheus to scrape console and use Alert Manager to alert us when a service goes up or down. We can also use Grafana to get the telemetry details from Prometheus and build a dashboard for us to see what our workloads are doing. More on this a little later, though, in a follow-up episode. Now, we are also creating these little service files. So we're telling it it's a service. The name is Vault. This is our DNS name. This is our address, and this is our port. And when we do these services, we can see that these are the services specified in console. But you will see that there are a number of extra services, and they are coming from Nomad. They are automatically being registered from Nomad to console. And after this console little session, I'm going to show you a little bit about Nomad. Now, console have got our nodes, and these are the checks that are registered against these nodes. Our Fabio check, and these are automatically registered from Nomad. We also have a key value pair, and this key value pair is being used by Fabio. Now, Fabio is a load balancer that runs on Nomad. It is zero config, and I think it was built by eBay back in the day. Super fast. But what we can then do is we can tell that Apache is on Fabio/Fabio, and we're pointing it where the service Apache is running from. So just know that we can use Nomad as a key value pair as well. Primarily, it's a service discovery, and it can help you determine workloads when they scale up and down. I'll go a little bit deeper into Nomad on a following episode, but after this, I'm going to show you Nomad. Thank you for your time, folks. Now, friends, let's talk about HashiCorp Nomad. By far one of my favorite pieces of HashiCorp products. Now, Nomad is a job orchestrator. It can run containers and non-containers like scripts or VMs. Nomad can run on-premise on your own machines in your data center, or it can run on the cloud on a VM. Nomad fits in the same sphere as Kubernetes. It runs workloads, auto-scales them, all of this. With that, let me share my screen and let's visit the Nomad website. So similarly to the other HashiCorp products, Nomad has got its own website with documentation. And in this documentation, you can get an intro into what Nomad is, how its API works. You can get to use some of the tools and plugins that Nomad has. If you go to HashiCube, I also run Nomad. And when you click on Nomad on the menu, you can get to Nomad here. Now, first off, you'll see a video by Arman Dadkar, the CTO of HashiCorp, explaining what Nomad is. And he goes into great detail about how you can use Nomad and why HashiCorp created Nomad in the first place. If you scroll down, you will see how we can provision Nomad and get it up and running. Now, with Nomad, I've already provisioned this for you. And you can see here that I have provisioned Nomad. I've typed in Vagrant up -- provision - with Nomad. And this is the output that I'm getting. Okay. First off, it tells me I can go to the Nomad website. Now, on my local host, port 4646, you can see Nomad. And right off the bat, what you are looking at is there's a number of jobs running on Nomad. Okay. If we look here to the left, there's some place for storage that you can mount inside of these containers, and also variables. So we can add a variable here and we can expose this to our workloads to keep everything nice and secure. Nomad can also run in a clustered environment. And so this is what you can see here by clients, in what data center they are, what version they are running, and then which one is our server, our leader. Okay. But back to our jobs. You remember when we spoke previously about Consul and its key value store that we use for Fabio, right? So now I get to show you where these routes are actually used. Now, Fabio is just another job in Nomad, and the Fabio container is running over here. Now, to get a little bit more insight into Fabio, we can go to the Fabio dashboard. And if we open up this URL, we will get to the Fabio dashboard. Now you see this Apache 2 service with the URL in here with the options. That actually comes from this value in our key for Fabio, in one of our keys for the config, the Apache key, this one over here. So Fabio is a load balancer made by eBay, zero config, and it's actually just a container running in Nomad. Now, I also wanted to play around with Trafic. And Trafic is also running as a Nomad job, and you can see it running over here. So if we open up the Trafic dashboard, you can immediately see the ports that Trafic is listening on, and that is this port over here. And you can see the load balancing port for Trafic, and a little bit of statistics like the router services and middlewares. We can also see that this is a Nomad provider, and using HashiCube, I also run Trafic, but on Kubernetes, on Minikube. So we can run Trafic on Nomad and Minikube side by side. I do this also with Waypoint. You can run Waypoint in Nomad, or you can run Waypoint on Kubernetes and deploy an application onto both of these orchestrators to get a full 360-degree view on how these things differ and how they are the same. Now, back to Nomad. If we click on a job over here, let's say we go to Trafic, and we look at this Trafic job over here, we can immediately just click and see the logs. Now, our logs is over here. We can also see standard error, and let's see if we can get a little bit of output from this. Let's see here. Maybe it's not this guy. Let's see here. Okay. Let's see the server, and we just want to view the logs. Maybe it is not in info. Maybe it's not in debug, so we won't see this logs. But I just wanted to tell you that you can get to logs from Trafic. So let me see if we can use this Trafic who am I. Let's see if we can view this logs. And if we just quickly see here, load balancer. Actually, we just want to get the who am I one over here. Curl. And we just want to get this little curl that we've got here. And if we curl it, post over here, we get a reply and the roots, and so we should be able to see the logs in here. Whoops, not Trafic. We're looking for Fabio. We're looking for the logs. There we go. And so if we go Riaan, we should be able to get this log over here. Now, let's see if this is going to work. We can also exec into a container. So let's see if this works. Whoops. No, this doesn't. Maybe SH. There we go. So here we are actually in the container, and we can now inspect things like the Fabio config that was set, and we can look at how we did that. We have in Nomad, we have Fabio.nomad, and that is the job. And we set this in etc Fabio, our little mount. So if we go here, we go ls-la for etc Fabio, then we can see our files that has been mounted inside of this Fabio directory. And we can then see for etc Fabio.properties, we can see our config file that has been in the container. So super handy. Nomad is a wonderful little utility. I really love it. In a following up post, I'll go a little bit deeper into Nomad, show you how we can cluster this across AWS, GCP, and Azure, and we'll delve a little bit deeper into this. But next up is Waypoint. Thank you, friends. Now, friends, next up is Waypoint. And Waypoint is a fantastic little utility specifically aimed at the lifecycle and workflows for developers. Now, usually there is two distinct parts of applications. So one is the developer workflow and lifecycle, where they just want to push fixes and new versions and this type of thing. But underlying it is the VM or the control plane where this application has to live. Someone has to control this. And this is where the operators come into play. Now, Waypoint is specifically aimed at relieving this contention between the operators and the developers. So with that, let me share my screen with you and show you. So if we go to HashiCorp Waypoint website, Waypoint project, we have the same website that we are used to with wonderful documentation from HashiCorp. Now, by the looks of it, Waypoint is moving more towards HashiCorp cloud platform. But with HashiCube, we are also running it locally. So inside of HashiCube, on top of Nomad, we are deploying Waypoint, and we can also deploy Waypoint on top of Kubernetes. So if we look at the Nomad jobs in the Nomad dashboard, and we go to jobs, then we can see here is a Nomad server, and there's two Node.js applications running here. Now, I've already done the Vagrant up minus provision minus with Nomad and Waypoint. And what this has done is it has deployed an application for us, and I'll show you where this application is defined. It's on Nomad T-Rex, and it has in its output got our Waypoint server URL where we can log in and see the status of this application and build and releases. It's also got a token which you are going to use. Now, if you type in this URL, you'll get an SSL warning. Just exclude that and move forward and log in with this token, and you will then get to see this interface right over here. Now, if we look at this Nomad T-Rex and we go in here, we can see that the deployments is over here. Now, here we can see our Docker build that has run. It's copying our application. It's using the Node.js base image, and it's running it for us, right? Then we can see builds, and this is where we built it, and it has published it to our Docker registry on localhost. Now, we can then see our releases is over here, but we can see there's two releases over here, right? So the first release, we can see that it's released it, and our version is version 1, 22 minutes ago. and the other release is version 2. And these are the two applications you are seeing actually here. Now, if we go back to logs, you can see that this is the startup log of the application itself, of our little Node.js application. But then it also gives this exec interface or capability to developers. Now, similar to Nomad, where we could exec into the job, such as this. Let's select this version, and let's go. Let's see if it works. No, this doesn't. Let's see. No, it doesn't work. Doesn't work for this one, but it does work over here. So if we go ls-la, then we can see our application code. And if we do cat, this waypoint.htcl, then we can see it's actually this waypoint.htcl that we are looking at. This is the same waypoint.htcl that we are looking at. Now, usually, by default, the URL service is enabled, which means that if I've deployed an application, it will print out a URL here, which is waypoint.run, and some randomized URL where I can access this application. We should obviously not use this for production because it's a free service from HashiCorp, but at least for developers, they can have a look like a canary, whether this app is running properly. So it didn't have this URL, but not a problem. We will use SSH tunneling. So we are going to say that we want to SSH into this machine on this port into our Docker container, our HashiCube instance. And we want to bind localhost 28605 to our Docker interface 28605. Now, where did I get this port from? I got this from Nomad. And if I look here, then I can see that this is where this application is actually listening on, this container. So if we bind this and we type Vagrant and we are in, we can now connect to localhost this port. So if we go here, then we can see our little Node.js application that it is actually running. And it is running on Nomad. You can do the same on Kubernetes, and you will also be able to access the nodes. And here at the bottom, it is telling us where we can find these files. So it says that this file is in views, pages, index.ejs. Now, if we go into view, pages, index.ejs, then this is our little T-Rex application. So friends, this is a brief introduction to HashiCorp Waypoint. Up next is HashiCorp Boundary, and I've left the best for last, Terraform, my favorite. So thank you so much for your time. Please stick around for the next section, which is HashiCorp Boundary. HashiCorp Boundary. What is it? So for those of you who's used ngrok before, Boundary will be familiar to you. What Boundary is trying to do is it's trying to give you a front end where you can access services that you have access to, backed by roles. So role-based access control. It also doesn't want to expose the credentials for you. It just wants to broker those credentials for you, give you access, and you're in. So it wants to give you temporary credentials, let's say to a database. You have a target to your database. You've got access to this. You can log into Boundary. You click something, it bounces to your localhost, and you can now set up MySQL Workbench to connect to this temporary address. And this is a tunnel straight to your database, meaning you cannot leak credentials if you don't even have the credentials in the first place. It sounds perfect, and it is. So with that, let me quickly show you what HashiCorp Boundary is trying to achieve. So again, you can go to boundaryproject.io and we can get to the documentation from HashiCorp. Excellent documentation that we are used to. Now, again, Boundary as an HCP counterpart, and also a community edition, which we use in HashiCube to play around and test how Boundary is working. Now, if you go to HashiCube.com, you can click on Boundary, and this will take you to this page. Here's a video from Armin Dadgar explaining what the purpose of Boundary is and where they are going with this. And then there's a few diagrams with a login and how you can use this. Here, I give you the Vagrant provisioner command that will get you up and running with Boundary, and the output will look something like this. Now, I've already done this. I've already brought up Boundary on my local host, well, on HashiCube. And so it has started it for us. It set a little bit of a config file for us here. It started Boundary in dev mode. And then it gives us this address that we can log into. So we can log in with admin and password. Now, I've not configured any targets or any roles or any groups really. I've just installed this for the purpose of this video. In a later video, we'll set up some targets, maybe with SSH and RDS, and we'll see how we can broker these credentials locally. But that's for a follow-up video. Up next is HashiCorp Terraform, and my favorite, since I'm a Terraform authorized instructor, and it was also the second tool I used from HashiCorp. My first one was Vagrant. So stay tuned for the last installment of this little episode for Terraform. Terraform. And with all of their providers and modules and their public registry, where we could do anything from procure AWS resources to GCP resources to Cloudflare CDN CNAMEs to GitHub organizations and repositories to GitLab to Dockers, anything we could imagine we could do. But how do we actually start writing Terraform? How can we start learning Terraform? And I'm a firm believer in doing creates this pathway from learning. If you start doing something, you're already in it, you get the flow, you can practice this again and again and again and again. And doing versus reading, to me, just makes it stick in my mind. So when I first started with Terraform, I sat 2 hours on the train from the Central Coast to Sydney into Sydney CBD or into Parramatta where I work. And I had these 2 hours to spend time learning Terraform. But there was one problem. As I went over the Hawkesbury River, I no longer had internet access. So I couldn't use my cloud resource. And I thought, wait, there must be a better way how we can do this. So I then discovered local stack. Now, before I delve a little bit into Terraform, I would just like to show you how I learned Terraform using HashiCube, using local stack. Now, local stack itself has evolved over the last 3 years I've been using it, and it's a fantastic little tool. Now, if you run Vagrant up -- provision - with local stack, Terraform, it will bring up a local stack Docker instance for us. Now, local stack is something that fakes AWS AMIs. And pretty soon, I think they're going to do it for GCP and Azure as well. But if you register on localstack.cloud, you'll be able to log in with your GitHub username and password. And I did that. And then you are greeted with this interface. Now, if we go a little bit down, we'll see there's a local stack instance. And if we click on status, we can see that these are all the resources we can kind of create with Terraform. Now, I'll show you some code now that I've left here for you inside of HashiCube. So basically, if you go to HashiCube and you click on this GitHub account, then you can go into local stack. And then what I've tried to do is give you a small example. So first of all, let's look at our main.tf. Well, we have the provider AWS, but we specify the endpoint to be the local stack endpoint, which is a Docker container running inside of HashiCube. And then we set up a little bit of locals, and I'll show you why I use this locals is I want to show you how to use this flatten and zip map and length and range functions to kind of loop through complex variable objects. And then we also have a null resource, which I use frequently for debugging. I wonder if this is big enough for you to see. There we go. That's a bit better. And then I have a random function, a random string resource that I use for this that you can use. And then also I create an S3 bucket, and I call this my bucket, amongst other things. I also create security groups, and I also create the rest I've disabled because it gave me an error at that particular time of day. Probably local stack has fixed this now, but this is what I do. I create the security group, right? So back to our directory, there is variables. Now, the complex variable that I'm going to use as an example is it's a type list and it's an object, right? With our type validation in here. But what this actually looks like, what this translates to is I've got 3 instances of this variable in here. So here's our first one, our AMI-ID with security groups and tags and EBS disks. And then here's the second instance of this list. And then here is the third instance of this list. And then we have some variable with 2 instances in this list, right? So if we go back here, when we run this local stack, Terraform Vagrant provisioners, then we will see that it's bringing up local stack for us, determining our architecture. It's checking that Terraform is installed. And then it's also installing AWS local for us. Now, AWS local is the same as AWS CLI, but it works specifically with local stack. And we're gonna do an example of this now. It's bringing up our local stack Docker container, and here it's running with our ports, right? And these are the ports that you saw in the main.tf. Now it is actually running Terraform init for us in our local stack directory. So it's initializing our backend. Then it's doing a Terraform FMT and Terraform validate to make sure that our code is valid. And then it's doing a Terraform plan. So that little S3 bucket I showed you, the code when we plan it actually looks like this, right? There's our buckets ACL that we are using. And then here's our security group that I showed you as well. Then there's our null resource count. There is our count 1 and 2 because we're counting over this. Then we have a debug. And we have our output, our disk allocation from our null resource consuming this complex variable object. And here is our first and our second and our third instance of this. Okay, so you can also practice yourself in here. And I'm going to show you how we do that now. Now, here's our random string in here. Now, if I go into HashiCube, I go Vagrant, SSH, and I go into /Vagrant, local stack, then I do, I can do AWS local S3 Alice. Just see, there's nothing in here because I think in my provisioner, I also destroy it. So here we apply it. And then I think here we apply it, we output it, and then I actually also destroy it. Okay, so that's why there's nothing there. But let's go Terraform plan. Okay. Now, this is exactly what our provisioner is doing. It's inside this local stack folder with our main variables and outputs.tf. And this is what it's going to do for us. This is the plan. This is exactly the plan output that we got, right? So let's go Terraform apply. And let's see if this will work. Should work. So let's give this some time. Now, bearing in mind that you don't need an internet connection at this stage. You can do everything local. You can practice all of this locally. Now, if we do AWS local S3 then we should see that we have a my bucket. So we have this my bucket that we have defined in our code, which is over here. And if we look for Control F, the my, oops, it's underscore my bucket, which is over here. So this is our little bucket that we have got over here. Okay. And then we can go Terraform state list. And we can see our resources that are in our state. Now, this is great for you to play around with because it's all local. It doesn't really authenticate to the cloud or anything. So you can go and muck around with the Terraform TF state, and you can go look what is exactly in there. You can go see what is in there, okay? You can also use Terraform import to import objects into your state. And so this is a really good little lab where you can start practicing Terraform. Now, let's say we just want to nano main.tf, and we want to go down to our S3 bucket, which is obviously a little bit up. That's my hyphen bucket, which is here. And we copy this and we paste this and we call it Riaan bucket. This to Riaan bucket. So yes. Let's see Terraform plan. What this is going to do for us now. So we run Terraform plan. It's refreshing our state. And it's telling it that, okay, this is just a timestamp that it's going to replace, but it is going to add Riaan bucket for us. It's going to add an S3 bucket, a fake S3 bucket called Riaan bucket. So let's do Terraform apply. And we just give it a second to apply all of this for us. There we go. It's refreshing our state. Yes. And if we now do AWS local S3 Alice, we'll see we have another bucket here, Riaan bucket. Now, I don't need a cloud account. I don't need an internet connection. I just need to get HashiCube up and I can already start learning Terraform. So what we've used here is Terraform, the community edition, the binary. So we can go Terraform-V, and this is Terraform binary that was installed. But there is also Terraform Cloud. And at the moment, you can go and create yourself a free account on Terraform Cloud. It doesn't even require a credit card. You can just go and create an account. And you can use up to 500 resources. So for example, HashiCube has got a Terraform registry module. Terraform, it's registry.terraform.io. Here's the Terraform registry with all of the providers and all of the plugins that you can get that people have written. Here's one for Waypoint, there's one for Vault, there's for Terraform. If we then go into modules, you'll see there's AWS modules, which you can just go and use. And if we browse the modules, you will see that there's a lot of these modules, right? So many of them that you can just go and use. Well, I've also went to go write one and to help me learn how to write Terraform modules. And if you open it here, you can then spin up HashiCube in the cloud. So there will be a follow-up episode where I will show you how to spin up HashiCube in the cloud, because sometimes you just want to use a boundary with some IAM backed in AWS, or you need to install, let's say, Terraform with cloud resources. And then it's just good to have this HashiCube locally, that you have locally, running on AWS or Azure or GCP, or all of them together, right? And so, for example, you can run Ansible Tower on AWS HashiCube, well, AWX Ansible Tower on an AWS instance, right? Now, that is what I wanted to show you, but I also wanted to show you on HashiCube. If you click Terraform, you can look at this video. There's another one from Armon. There's two over here. Now, I'll tell you a little bit about modules and providers and how we use them and how they are used. But then I'll also go into Terraform Cloud. What is Terraform Cloud? I give you links to Terraform Cloud, and there's a video from Mitchell Hashimoto, who created HashiCorp in the first place, explaining where does it fit in. Now, there's a couple of advantages using Terraform Cloud. So one of them is your state is encrypted and your state is taken care of. You don't need S3 buckets, you don't need DynamoDBs, none of that nonsense. It's all taken care of for you by HashiCorp, which is great, right? And then secondly, one of the excellent features of Terraform Cloud is the drift detection. So you can already see, let's say you deploy an application into AWS, and some of your colleagues goes and changes this EVS, this size, the tags or whatever, you can automatically see, aha, this resource has drifted. It is no longer the same as the configuration that I've defined in code. And then one third benefit of using Terraform Cloud is, let's say you have a cloud account in AWS. That's super easy. You have a pipeline to deploy your Terraform, use the community edition, that's great. You know exactly what the status of this is. But let's say you have 50 applications or workspaces. Let's say you have 100 of them in different clouds, AWS, GCP. How are you going to tell your organization exactly the state of your infrastructure? The version of Terraform, the version of the modules that are being used, the state of their last apply. Did the apply fail? I don't know. Well, with Terraform Cloud, you can get a bird's eye view over all of your cloud accounts and all of your workspaces. And this is incredibly powerful, especially when you work in a small team servicing many developers, right? So in here, you can go and clone HashiCube, the multi-cloud module yourself, or use the Terraform registry module. Here is the variables that I tell you to add in your Terraform Cloud secret store, the variables. Then if you deploy it, if you run a plan, it's going to look like this, right? On all the clouds. You can see here there's AWS, there's Azure, and there is GCP. And then there's also Terraform Enterprise. Now, Terraform Enterprise is aimed at government departments or departments that need data sovereignty. So their data needs to be stored in, let's say with GDPR, they need their data in German soil. Let's say with Australia, they need their data in Australia physically on the continent. So this is what Terraform Enterprise is. But not least is Packer from HashiCorp. So what is Packer? Well, Packer is an incredible little tool. Packer builds identical machine images from a Packer template, meaning that our machine image is defined in code. Packer is much like every other HashiCorp tool built on this plugin architecture, meaning that in Packer, we can use Ansible to do some tasks for us in this provisioning step, or we can use bash scripts or PowerShell, And moreover, Packer can build Windows, Linux, whether it be Yum-based or Debian-based systems. It can build it on any cloud, even Vagrant and VMware images. It is incredibly powerful. Now, let's delve into this. And with that, I'll share my screen. And I want to show you again. If we go to packer.io, we get to the Packer website from HashiCorp. Again, the documentation is feature-rich, and you can get anything here, from plugins to provisioners to builders, right? And if you go to the HashiCube website, you can also read up about Packer and how I use it. At the top, I've left you a video by Arman. It's explaining what Packer is and where it fits into this. Now, Packer is a bit different. Since I run HashiCube in a Docker container, I can't really run Packer. I have to run Packer in a machine that supports whatever machine image it's building. For example, Azure AMI, it's going to build on the cloud. Amazon EBS, it's going to build an AMI on the cloud. And so we can define all these builders at the top, even Vagrant, even Docker. And that is a small little piece of information. It is just what is the source image and where we are pushing this artifact to. Then at the bottom comes the real juice in the build code block. Now, here I've specified a provisioner Ansible, and this is using my Ansible role example role to build this machine. What this example role is doing is it will add a user, an Ansible user, and it will fingerprint the OS, the AMI. So it will take the Ansible host vars and write it to a file, meaning that when we have these images running around as VMs running, and we find a bug somewhere, we can go and interrogate this VM and see, okay, this was the version that built this VM in the first place. And we can stitch all of these provisioners together, and by the end of it, we will have a template. Now, here I've left you an Ubuntu 2204 template, and I've given you a Windows 2019 template. However, a couple of days ago, I created a project on GitHub. So if you go to github.com / actually, if we just do this easy, we click on this GitHub icon over here. We go to my home profile, we click on repositories, and we go to Golden Image Builder. Well, folks, here you will see an advanced Golden Image Builder, complete with GitHub actions and everything you need. So, as always, most of my repositories come with a VS Code dev container. And in this dev container, I install things like Packer, Terraform, Ansible, and all the cloud CLIs that I may need. I also use this container for my build agent. Then I run run.sh, and what run.sh does is it checks my code for any syntax errors. It does a Terraform lint for me, it does a YAML lint for me, it does a tfsec scan my Terraform, and then lastly runs through some pre-commit rules. For example, it checks for AWS credentials or private keys so that we don't leak any secrets. Then, next up, I build Azure Image Gallery. Now, an Azure Image Gallery is where Azure stores its machine images once you've built it. You do not need this in Google Cloud or in AWS. AWS merely has an AMI that registers backed by a snapshot, which is EBS. But I also built this image gallery from Terraform Cloud. And for that, I use the API integration. Then I run my Packer build. And my Packer build looks something like this. It boots up the machine. Then it runs my Ansible role. It gets a couple of facts for me. It writes the fingerprint to the file system. and it adds the user. Make sure that the Ansible user is present. And after that, it will package an AMI and create this AMI for me. That's the AMI ID. Then next, I use HashiCube multi-cloud module to spin up an Ansible AWX Tower instance. I do this for day 2 maintenance of these images. So, and I'll show you quickly how that file looks like. And then lastly, I run this Ansible instance also on Terraform Cloud. So I deploy this via Terraform Cloud. Now, without Terraform Cloud, it's just a plan that shows me the variables I pass to the HashiCube module. And maybe if I can show you what this looks like, we will go to our files. And so in here is our repository with our variables for our Packer variables. And inside of Packer, we have Linux, which is CentOS, Debian, Red Hat, and Ubuntu. And inside each of them, I have a little file, which is my Packer template. And this is what my Packer template looks like. Okay. Then outside of Packer, I have Ansible, but there is nothing really in there. However, there is this requirements.txt file, .yaml file, and I use Ansible Galaxy to fetch all of these roles for me. So although it looks like a monorepo, it's not a monorepo. Then in here, I have a Terraform folder, and this Terraform folder has this AWX Ansible Tower in. And as you can see, all I'm really doing is I'm using this HashiCube module from the Terraform registry. I pass a couple of parameters to it, and I spin it up. And then this will do some of the magic for me on day 2. Now, I've also have a Medium article, and I will link this in the YouTube post to follow. And if you search for Golden Image Builder, you should get GIB, the Golden Image Builder, which is an article that I posted on Medium, taking you through how you can use Packer to build machine images. So, for example, here we are building Red Hat 7.9 on Azure, Amazon, and Google Compute. We're also building a Red Hat 8.4 on Azure, Amazon, and Google Compute. Similarly, an Ubuntu 18.04, an Ubuntu 20.04, and an Ubuntu 22.04. A Windows 2016, a Windows 2019, and a Windows 22. We are building this all in parallel on all 3 clouds. So, in a follow-up post, I will delve a little bit deeper into what Packer is, how we are going to use it, and we'll touch on Ansible roles. For now, this is a brief introduction to HashiCorp tools. Thank you, friends. Thanks for a lot for giving me your time and listening to this presentation. I hope you've enjoyed it as much as I enjoyed creating this for you. I hope you have a wonderful day.